I really feel that this is going to be a really fantastic one. So I'd like to welcome Ismael, co-founder and COO of Lagrange, who is going to speak to us today on a proof-based future with Lagrange. Over to you, Ismael.
Thank you all for having me. So my name is Ismael. I am the co-founder of Lagrange. Let me just find the clicker real quick. And so the topic for my presentation today is building a proof-based future with Lagrange. So for those of you who are watching this at home, we're in Bangkok right now, and the traffic to get here was ridiculous. It took me forever to get anywhere in Bangkok. There's traffic almost on every street. And so I was on a motorbike getting here, which was going very, very fast and weaving through cars, and I was sitting on the back of it. And while I was doing that, my life was flashing in front of my eyes. I mean, right, this thing goes over, and then I just go splat. Not good. And so when this was going on, I started thinking, like any normal person naturally would, about ZK and blockchains. And I started thinking about when I founded Lagrange. And I started thinking about a conversation I had in San Francisco several years ago. And the person said to me, the man I was speaking with at an event just like this, that the future of blockchains, every application would be a cross-chain application. But at the time, it felt very fanciful to me. Like the idea that a parachain on Polkadot would compose with a DEX on Cardano wasn't really realistic. But looking forward to now, well, it was a very prescient prediction because I can't think of a single DEX that doesn't take wrapped assets. And I can't think of very many DeFi protocols that don't have cross-chain or multi-chain deployments. And so that got me thinking, if that was a bold prediction in 2021, what's a bold prediction today? What's one that's equally impactful to the direction of the space? And that prediction for me is that every single application in crypto will be a verifiable application. Every application will use ZK. It will compose with off-chain data through ZK TLS, or it may extend its execution with a coprocessor. Or very simply, it might sit on a blockchain that has verifiable execution. I mean, Justin Drake talked about this yesterday. Ethereum's moving in this direction, and I'm assuming every ZK rollup will take over as well. And so Lagrange, put simply, is the substrate for that future. From the evolution from proof-of-stake blockchains and proof-of-stake middleware, all the way through the erosion of the hegemony of crypto economic solutions, to a future where everything fundamentally is verifiable. Now, what is Lagrange beyond something I tell stories about at conferences all over the world? It is an economy of proving. It is a universal and infinitely scalable layer to generate proofs for any application and every application. And it does this by hybriding between performance, specialization, and universality. Lagrange is actually in production today with a subset of our customers and our partners where we deliver proofs already to DeFi and NFT projects, as well as cross-chain protocols. We distribute proofs from our ZK coprocessor into protocols including Azuki, EtherFi, Gearbox, and more, as well as proofs into cross-chain protocols such as Layer 0, Axelar, and Polymer. But what we are building is much greater than that. There are a number of core partners who will be deploying on Lagrange over the next several months, and we can't wait to announce more. Our provers are being run on this decentralized economy by some of the best institutional operators in the space. These aren't at-home hobbyists. We're not in the basement era of zero knowledge. These are institutions: Coinbase, OKX, Kraken, P2P, Figment. 85 institutional operators are running provers for our customers. What makes us so special? What makes this architecture so generalizable? Well, the key is that we don't build a universal monolithic prover network, right? We build a network of networks, an internet of proving. This is composed of 3 basic building blocks that form each subnetwork: gateways, which run auctions; provers, which bid on auctions and generate proofs; and then orchestrators, which are responsible for taking inbound requests and designing a bespoke computational graph. Across these 3 components, you can build decentralized proving for anything and everything. How's it work? Well, in production today, when a customer sends a request, we receive it, or a gateway receives it. It generates a task that is auctioned off into a pool of provers who bid on it and have a stake that, if they win, is put on the line to generate it within a certain time frame. In the event that they bid the lowest bid and they win the auction, well, they have a time slot to generate that proof and return it back to the auctioneer. And if they do so, well, they receive a reward. If they don't, they receive a sanction. Okay. Now, how does this differ from every other single prover architecture that I see proposed? Well, the difference is that it's not monolithic. There's not a single gateway with shared bandwidth that bottlenecks. As the number of types of proving increase on this network, there is not a loss of performance for generality. The network can specialize while remaining universal, horizontally scalable, dedicated bandwidth, a network of networks, universal across the entire stack. And this means it can scale. It can scale to the proving demands of a decentralized economy the size of the blockchain space. If every app is a verifiable app, there must be a substrate that can scale alongside it, and that is Lagrange. And because of the performance of each of these subnetworks, a developer who wants to compose on top of zero-knowledge proofs, who wants to use them in their application, or wants to build their own logic that needs its own prover, can easily deploy a subnetwork for any popular proving system without having to worry about spinning up their own network. And the incentive compatibility of this is something else that is very important, right? A lot of teams out there will say prover network, prover market. And what they're really saying is, I built a proving system and I need a token. So how do I do that? Well, I launch a network. That's not really what we think the future of decentralized proving is. The point of a blockchain was not to sell an execution client. The point of a blockchain was an efficient mechanism to assert a global transition of a state machine. And the point of a prover network or a prover market is to generate proofs with a high guarantee of liveness. And so how the network is built has to reflect its purpose, and how a market is built has to reflect its intention. And so there's some phenomenal work from our research team that we submitted to Financial Cryptography FC this year on a novel double auction design for resource allocation. We call this DARA. And what it effectively is the first example of auction theory being applied to dynamic resource markets for proof generation. And what we do is define a set of formal properties under which an auction is incentive compatible, things like collusion resistance, things like budget balancing, computational efficiency, welfare maximization, a set of 5 properties we define. And then we formally prove that the mechanism that we propose is able to address these. And what that means for a user is cheap proofs. And what that means for someone deploying a subnetwork is that you don't get ripped off as you have scaling proof demands. You get to build in the best tech. And so high liveness and cost efficiency, economies of scale, and efficient resource utilization and optimized resource allocation. This is what makes Lagrange unique. Now, because this infrastructure is production ready, it's been in production for the past 6 months, it means you can be hands-off. If you want to deploy provers in production today with Lagrange, you can do so. There's nothing stopping you. The network and the infrastructure takes care of everything. A very simple example I like to say is if you want to deploy a ZK rollup in production today, you wouldn't roll your own circuits. Well, you would use ZK Sync, you would use Polygon CDK, you would use Scroll, or you'd use Starkware. It's a stack that's replicatable for application-specific purposes. That is what this network by design is. And so I've been saying a bunch of times today that it is production grade. I mean, everybody likes to use this word production grade, but very few things in crypto are actually in production. So far, our ZK coprocessor has been in production, actually production, for the past 4 months. And this is a SQL-based ZK VM that sits on top of our network. And what this means is, if you want to write computation over blockchain data that's verifiable, think of Dune Analytics, but with ZK, you can do so. Your contract can access compute over historical blockchain data without having to lose any type of trust assumption over where that data is derived from. So if this sounds confusing to you, just think, anything I can write in Dune Analytics or Nansen, I can prove to my contract. Airdrop rewards, points, incentives, you name it. Let your creativity run wild. Now, how does it work? Well, your contract registers a data frame on chain, a series of events, storage slots, or receipts you want to access. You then can generate a proof of any type of arbitrary SQL query over that data, and that request is whisked off-chain to our network that, just as I talked about before, generates a proof on a production enterprise-grade set of provers that is delivered back on chain, such that your data, such as your contract, can handle an asynchronous callback and use that data. And so I want to spend a moment and walk through some real use cases of customers building cool things on top of our prover network. EtherFi, one of the largest LRT protocols in the space, about 5.5 billion of ETH in TVL. Well, they're building a on-chain credit card to borrow against your balance within their DeFi protocols. But to build an interesting on-chain product, specifically something as important to everyday life as a credit card, you can't compromise features. And if you don't have cash back, well, nobody's going to use your credit card. So EtherFi has a 3% cash back, rather high for the market and fantastic to attract users. But in order to do this, they need to be able to prove the amount you've spent over an interval of time. If you're a developer out there, just think to yourself how you'd build that in Solidity to let an arbitrary claim logic over arbitrary time for users spending an on-chain credit card. It would be very hard, it would be expensive, it would be cumbersome, and it would probably spend more in gas than you actually were able to give the users in cash back. With a ZK coprocessor, we can handle that almost instantaneously with a proof. And something a little bit more fun is some work that we did with a top NFT project, Azuki, a team that sits at the intersection of anime, Web3, and entertainment. Well, they have badges and collectors programs that are generally done off-chain. Lagrange provides a substrate to bring a consumer-native experience, a collector program for end users, onto the blockchain using ZK. And finally, Gearbox, a modular lending protocol, credit abstraction. Well, Gearbox correctly identified that there is a series of standards used in DeFi that were built in the last generation of on-chain applications, or last generation of engineering. And all of these standards built in Solidity don't use ZK, they don't use co-processing, and they don't benefit from the new innovation in underlying cryptographic primitives. And so Gearbox resolved, well, what if we take some of the most used standards, something like the Sushi Master Chef standard, or the 1-inch farming pool standard, and we build it from the bottom up to be capital efficient and resource efficient with zero knowledge. And the result is some of the work that we've done with them. Anyone interested, I recommend you go check out some of Mikhail's tweets. They're fantastic, and he walks through all of this in great detail. And finally, the last thing I'd want to add is that if you want to be involved in Lagrange, I would suggest that you reach out to me or our team, and you follow us on Twitter, or you go experiment with our open source code. And as a final message, I really want to encourage developers to think what you'd build if the computation your contracts could access were unbounded. We developed a lot of things in crypto, not because they were efficient, but because we could with the technology we had at the time. Now, we are 3 years after the fact, after the time that most of these DeFi apps were built for the first time. And there's a host of new tools you can use to build trustless new primitives within them, all the way from consumer to DeFi to NFTs to anything that you might want to deploy on chain. And I'd suggest that developers think to themselves, not what can I do with the technology that was available to me, but if I was unconstrained by technology, what would I build on chain today? Because very soon the computation you might want to access from your smart contract will have no more constraints preventing you from doing it. So thank you so much, and thank you for hosting me. And if anyone has any questions, feel free to catch me after.